Hello everyone, welcome back to the channel. So today we'll be solving the problem of the day, which is count good triplets, and we'll be solving it live. Okay. Given an array of integers ARR and three integers A, B, and C, you need to find the number of good triplets. So how do you define what a good triplet is? A good triplet is array I, array J, array K. The following conditions are met. I is less than J is less than K, and all of them are valid. Array I minus array J is less than equals to A. Array J minus array K is less than equals to B, and array I minus array K is less than equals to C, where modulus of X denotes the absolute value of X. Return the number of good triplets. So since the array length is quite short, I think we can do a brute force solution over here without thinking anything else. Let's first do brute force, right? So what I'll do is I'll just take int n is equals to nums dot size, right? And then I will have how many array of I minus array of j should be less than equals to a, j minus k, and then I minus k. So 3 and I equals 0, I is less than n, I plus plus. Now the thing is that uh-huh that j needs to be strictly greater than I, right? And then k needs to be strictly greater than j. So for when I'm going to start my j, I'm going to start it from I plus 1 and not from I, basically from I plus 1. J is less than n plus, and similarly for k, I'm going to do for in k 0, k is less than n, k plus plus. I'm going to see three things, right? So three things. If absolute of what? Absolute of array I minus array j. Array of I minus array of j if it's less than equals to a. And absolute of array of j minus array of k, j minus array of k is less than equals to b, and array of absolute of array of I minus array of k, absolute of this should be less than equals to c, right? Yeah, less than equals to a, and this and this. So if it's the case, you do answer plus plus. In the end, you have to return the count of good triplets, so you return the answer. For that, we'll have to initialize the answer as 0 as well. So if I run the sample test cases, array of I minus array of j, what's wrong? Nums, acha, it's ARR. Nope, 26 when it was 4. And this gives me 7 when the expected answer is 0. Why? Why? 301197. So root of array of I minus array of j should be less root of this thing. Yeah, I think it should work now. No, array of I, absolute of array of I minus array of j less than equals to absolute of array of j minus array of k is less than equals to b, and absolute of array of I minus array of k should be less than equals to c. Uh, plus 0, not 0, j plus 1, right? 0. and this passes all the test cases. So if it does, you don't actually need optimization in this question. And as like we said earlier as well, if you don't need optimization, don't think about it. Just solve the question, move on to questions which have much harder constraints which actually require optimization. So always do optimization in those questions where there is a need, where when you don't do optimization, you're going to get time limit exceeded or memory limit exceeded. Okay, so I hope you found the video helpful, and I'll see you in the next one.